Hi everyone, in this video we are going to be talking a little bit about the distributive property and really helping you get started on homework number 6. In homework number 6, you will use the distributive property to calculate the area of several different rectangles. So let's go through problem 1 together so that you can feel really confident answering the rest of homework 6 on your own. So I have the image from number 1 here, and you can copy this, you can follow along and use this as your first problem to homework 6. So the directions tell us in each diagram below, a large rectangle has been made from 2 smaller rectangles. So you can see here with the cursor, this is one big rectangle made up of 2. There's one, here's the other one, 2 smaller rectangles. In each case, we're supposed to show 2 different ways to calculate the area of this large rectangle. So we're going to use the distributive property in both expanded and factored form to show how to calculate the area of this rectangle. So just a little note to ourselves. I'll write it up here. If hopefully you remember that area of a rectangle, let's say this is the width and this is the length. The area is, you're calculating everything that's inside, and that's just width times length. Some people say length times width. It doesn't matter because of that awesome property, the commutative property of multiplication. But I'm getting off topic. Let's get back to the distributive property. All right. So we will show how to calculate the area of this rectangle in 2 different forms. So I'm just going to write expanded form on this side of the page, then divide the page up a little bit for myself so I don't get my work confused. And then also I'm going to show how to calculate the area in factored form. All right. And hopefully we will get the same answer in both different ways. So let's start off in expanded form. So I'm going to come over here and look at this rectangle, and I see these 2 smaller rectangles, and I'm thinking to myself, what is the side length that they both share? So I noticed that in this rectangle and this rectangle, they share this side length right here. It is hard to draw straight lines in this drawing program, so bear with me. All right, so they shared this side here. I'll outline that in blue. And then this other rectangle has a side by itself right here. And then you can see that this other rectangle over here does have one side length that's blue, and then a separate one, we'll just call it green. Just wanted to show you that we're working with a couple different dimensions here. All right, so let's get back to expanded form. So how would we calculate the area of this smaller rectangle here? Well, let's find out what these side lengths actually are. So the nice thing about number 1 is that they have little blocks for us. Instead of giving us just the dimensions, we have to count. So let's count what this is right here, the width of the large rectangle. So we have 1, 2, 3, 4, 5. All right, so I'm going to write that that's 5 right there. This smaller length is just 1, 2, 3, 4. So I'll write a 4 down there. And then we have 1, 2, 3, 4, 5, 6, 7. That's 7. And I'm just going to go back because I want to be mathematically proper. And since we're not given any units like centimeters or inches or yards or anything like that, I'm just going to write 5 units, 4 units, and 7 units. So when I calculate area, I'll actually get units squared. All right. So in expanded form, I want to calculate the area of this rectangle and then add it to the area of this rectangle. So I know that the dimensions of this rectangle here is a 5 by 4. So to find the area of that, I just multiply 5 times 4. So I'll write that out as 5 times 4. If you remember, our new way of writing multiplication are these parentheses. So this means 5 times 4. And then as I'm finding the area of this large rectangle, I'll have to add the area of this smaller rectangle to the area of this smaller rectangle. So I'm going to add it. And then what are the dimensions of this? So I've got a blue width here, that's 5 units, times this here, that's 7 units. So I have 5 times 7, and that is these are the numbers that I'm going to multiply together to get the area. So 5 times 4 is 20, plus 5 times 7, that's 35. 20 plus 35, that's 55. And remember, we're going to add in our units, so I'll say that's 55 units. And we multiplied units times units and units times units, so we have units squared. So that's what I get if I work in expanded form. Let's see what this will look like in factored form. So factored form basically says, well, I know that these two smaller rectangles here share the side length here. So instead of adding the area of these two smaller rectangles together, I can just multiply two things together. I can multiply this width by this length here. And instead of expressing the length of the big rectangle with one number, I'm going to express it as a sum of these two lengths. So let me show you how that's written, and then we can talk about it a little bit. So in factored form, I'm going to just multiply width, which we know is 5, times length, which the length is 4 plus 7. Right there like that. So now, whoa, I'm erasing a bunch of stuff. Now I can go ahead and figure out, well, what is 4 plus 7? I'll do what's in parentheses, and I'll say 5 times 4 plus 7. 4 plus 7 is 11. 5 times 11 is 55. And here we also multiplied 5 units times 11 units. So I'm going to write 55 units squared. And so we end up getting the same thing here. Now, as I was saying, we do know what this whole side length is here. We could count there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We could just multiply 5 times 11 here. But by adding in this step here, we really start to understand what's happening in the distributive property. I could do what's in parentheses first, just like I did, 4 plus 7 equals 11. But also you could see I'm taking this 5, what's on the outside, and multiplying it by 4, which you see here, which is 20. And then adding it to 5 multiplied by 7, which you see over here in 35. We'll be working more on this in the next few days, but I hope this helped you get started on homework number 6, problem 1. In each problem for the rest of part A, you'll be finding the area of those rectangles in both expanded form and factored form. Good luck! Thanks for watching.